All right, in this video for the calculus class, we are going to use arrow diagrams to apply the chain rule to find the derivative for a couple of functions. We want to demonstrate how to do that here. So the first thing that we need to do in this first problem of taking the derivative of the square root of x squared minus 5, the first thing we want to note is that what's under the square root is not just an x, so this is going to require a chain rule. There's something more complicated going on. So we start with the x and we build the arrow diagram, which is going to involve, first of all, squaring to get an x squared, and then subtracting 5 to get the x squared minus 5, and then finally taking the square root, which we will represent as the 1/2 power. Now the process of doing this with the arrow diagrams, then we draw the arrow down for the derivative of the squaring function, which is 2 times whatever it is. The derivative of x squared is 2x, but we leave those parentheses blank. The derivative of x minus 5 would just be 1, so that becomes a 1. And the derivative of something to the 1/2 power is 1/2 times that something to the negative 1/2 power. Now we check to see if there's what goes in the parentheses. So this was on this first arrow over here. So the input of that goes in there. No parentheses in the second part. The third part, we have a set of parentheses, so we consult the arrow, the input at the beginning of that arrow, which was an x squared minus 5. And then we multiply all of these things together and simplify. So the 2 and times the 1/2 are going to cancel, but I am going to have an x. So my derivative with respect to x of the square root of x squared minus 5 is going to be an x over the square root of x squared minus 5. And so there is our first problem. That's the derivative that we were looking for there. Let's see if we can muck that up a little bit with something a little more complicated. We start again by making the arrow diagram. So we start with the x, and we have to multiply that by 5 to get a 5x. That 5x then goes into the secant function to give us a secant of 5x, which then goes into the sine function to give us the sine of the secant of 5x. It's important that we recognize here that to get a sine squared is a function on its own, but if we don't know what the derivative of it is, we're not going to put it on one arrow. So the next thing we then need to do is square, and that's going to give us the sine squared of the secant of 5x. And then finally, we're going to multiply by 2. So come through, do the derivatives. Multiplication by 5 generates a 5. The derivative of the secant is the secant tangent. The derivative of the sine is the cosine. Derivative of something squared is 2 times that something to the first power, and the derivative of 2 times something is just a 2. And we come back through and look for parentheses. This 5x is at the beginning of the secant arrow, so that's the input for these derivatives, and we need to get a 5x into both of those. I didn't leave myself a lot of space here, but this secant 5x needs to go into there. I'll throw that in there, and then didn't even leave enough space here because this whole sine of secant of 5x needs to go into there. So we have the sine of the secant of 5x that goes in there, and then just multiplication by 2. You have all of the pieces we need to multiply all of those pieces together. I'll look for numbers first. I got a 5, a 2, and a 2. That's a 5 times 2 is 10 times 2 is 20. So I'll lead off with a 20. And then what else do I have? I have a secant of 5x, a tangent 5x, a cosine of the secant of 5x, and a sine of the secant of 5x. So I have all of those pieces. If I look through, I don't see anything there that I can combine together. So this is the derivative with respect to x of 2 sine squared of the secant of 5x. Just that easy.